Hello, my name's David Reed. I'm the admissions tutor for the Science Foundation year, and I'm going to give a brief information talk about our programme. So what is the Science Foundation year and who is it for? Well, it's a route for students who want to study scientific degrees here at Southampton who don't have the correct prerequisites for entry to the programme. Most students coming to study a science here will have done A-levels in relevant subjects. We offer a different route for those people who don't have the usual entry requirements. I'll talk more about who it's specifically for on another slide. In terms of the structure of the programme, well, we're mostly made up of three subjects, which are biology, chemistry and maths. The chemistry and biology modules are 30 credit points each. The labs and coursework module is also 30 credits in size, and that includes lab work, associated practical write-ups and other coursework assignments, which I'll talk about in a bit more detail shortly. The maths module is smaller than the chemistry and biology, it's 15 credit points in size, and there's another module called Routes to Success, which is a skills module that includes scientific skills and study skills and transferable skills, all things which will serve you well going forward onto the degree programme you'll go on to study. As with all of our other degree programmes, that means the year is 120 credit points in size in total, so it's equivalent to what you'll see later on. Now, assessment is done by a mixture of exams and coursework. Actually, the three subject modules, the chemistry, biology and maths, are all assessed entirely by exam, and there are exams in January and also in May. In terms of the coursework, this is within the labs and coursework module, and that will include assignments that align with biology, chemistry and maths, and the Routes to Success module also is a coursework-based assignment. In terms of the coursework that you'll do, as I've mentioned, there'll be lab reports, there'll be essays, there'll be presentations, there's a group poster assignment which is done as part of the Routes to Success module, and there are other skills-based assignments. As I say, these are key because they help you develop the skills you're going to need to be successful as a scientist going forward. And perhaps in some of these areas that our course offers some advantages over A-level, but we'll come back to that later. So in terms of who it's for, it's not for students who've got low grades in the sciences. So imagine you wanted to study a chemistry degree and you were doing chemistry, physics and maths, and you had CCD. Our programme would not typically be aimed at students with that kind of background. We're actually primarily aiming at students who have the wrong subject combinations. So for example, people that might have done English, history and politics. But what we would tend to look for would be students who had a good prior track record at GCSE level or equivalent in the sciences and maths, and that's an important prerequisite. Students with very low grades, certainly if we're looking at 4s or below at GCSE, again our experience shows that those students do not have sufficient background normally to be able to access our programs. But we do look at each case individually and take into account any special circumstances along the way, so don't be deterred. We will always talk to you to find out if our programme is suitable for you. We often have students who've done BTEC type qualifications, particularly if they haven't achieved the very top grades there. Sometimes these BTEC courses don't provide sufficient background for students to thrive on a degree programme where they're up against students who've got A's at A-level. And that's not in any way to demean what a BTEC qualification does. It actually provides a whole range of other skills. But if a degree is underpinned by a depth of knowledge in a particular discipline, then it may be important to do a foundation year to bridge that gap. There are also access courses which run in further education colleges around the country. Now again, high-performing students on programs that provide them with sufficient background may well have access for direct entry to degree programs, but we've on many occasions had access course students who've done extremely well in the foundation year and have said that actually the year was really important for them in helping them to then go on and achieve a top grade, if you like, a classification when they get to the end of their degree. So again, each application is treated on its own merits, but we do often look at access course students and consider them for the Science Foundation year. Now, we will also often consider mature students, so people who haven't studied for a number of years. Again, in these cases, we almost certainly will interview, and I tend to put students through their paces on some aspects of the chemistry, because chemistry tends to be the subject on the course that people struggle with the most. That would be something that we may offer to other students too, not just mature students. Again, ideally we'd be looking for people who have some kind of prior track record, perhaps some grades at GCSEs or O-levels for some of our older applicants. And if they have that background, then sometimes it's just a case of actually refreshing it. In some cases, we might advise students to go and take an access course, or perhaps study independently at GCSE or take an Open University module just to prepare themselves for the rigours of study, because once you've been out of education for a period of time, it's actually quite a big step to then go back. We do also have a number of overseas students. In a lot of countries, people undertake 12 years of study at school rather than the 13 that we have here in the UK. That means that the qualifications that students leave school with don't always provide them with sufficient background to be able to access a degree with direct entry. So the foundation year can be a useful way not only of actually bridging or plugging any gaps in the knowledge, but also helping those students to adjust to education in the UK and being taught in English. So it's often been a very valuable bridge for those students who've often gone on to then perform very well on the degree programme that they go on to. Now, just to revisit what I said right at the beginning, the programme is not primarily for students who have low grades in the sciences, but on occasion we know that people have difficulties, illnesses, circumstances that affect their studies at A-level, which result in them getting lower grades than they'd originally hoped for. And particularly if this was a result of them missing some school, either in year 12 or year 13, the foundation year may be a good option for those students, because obviously they can restudy the material and plug the gaps and leave the foundation year with confidence going on to a degree programme where they're more likely to fulfil their potential. So again, students who've had some kind of unfavourable circumstances or mitigating circumstances which affect their progression at A-level, we often consider them, although we may ask for some medical evidence to back up what's being claimed, so we can make a justification for taking somebody with lower grades. These tend to be quite rare cases, but as I've said, we will take each application on its own merits. In terms of the programs you can go on to, one of the benefits of the foundation year is that actually you have pretty much a free choice of a large number of programs as long as you pass. And passing on the foundation year means achieving 60% across the board. So the programs you can go on to are from our biological sciences programs. These programs listed here. Neuroscience has been a recent addition which has proved to be popular. We have many students going on to biomedical sciences, but large numbers going into the other programs shown there. You can go to chemistry and do a chemistry degree, and there are a number of different options available there. Environmental sciences is another one which is popular with students who have a particular interest in this area. And there are also programs in ocean and earth sciences, which include geology, oceanography and marine biology, and even geography is an option now. And actually, if you wish to go into audiology, it's also possible to study on our Science Foundation year. The reason there's an asterisk here is because there are additional entry requirements there. This is a patient-facing discipline, as nursing might be. So it's important that the admissions team in audiology assess your preparedness to go onto that kind of program. So you can still come onto the foundation year, but there will be additional interviews and other activities you have to undertake if you wish to do audiology. So please get in touch with us if you have an interest in that particular discipline. There may also be other options. We've had students who've come in and have decided partway through the year that they don't feel they're suited to a science degree. They've gone on to complete the year and perhaps transferred to another discipline such as psychology. So I mention that here. It's not that it's a direct route or option that you can take, but we will support our students in being able to explore other options if they feel that science isn't the way forward for them. So in terms of how the programme looks, and I should say actually at this point that this is how the programme would look in a normal year. We don't know quite what the academic year 2020-21 is going to look like, but I can convey how we structure the program, and whatever we do end up doing in the next academic year, the makeup of the work that students will do will not be too dissimilar to what we see here. So this is the overall timetable for the program. Don't panic too much. You would not be in all of these sessions here. Actually, the yellow sessions correspond to lectures, and these are the sessions that the whole cohort would be expected to attend. Now with the labs, we divide the cohort into two groups normally, and you would do a lab on Monday or on Tuesday, and that would be the pattern for the whole of the year, in normal circumstances, I stress. In terms of what we see here for Thursday, you can see that everybody would attend this maths lecture, and then over the course of the day everybody will do a maths and biology workshop. But you would only be in one of the groups as per the colour coding here, so you'd either be in the blue group, the red group or the green group. You would only attend the sessions which are in that particular colour. Other students would attend the other sessions. Friday is quite similar in that you would have an hour chemistry lecture in the morning, and then you would go to one of the three different workshop groups as per the colour coding you see there. So for an individual student, the timetable would look something more like this. As I say, everybody would be going to the yellow sessions, but an individual student would just go to the sessions in blue. And if you add all of that up, that means that the contact time is about 18 hours a week. There is also, I've just not mentioned this yet, but there's also a language support session which is entirely optional. Actually, this is primarily aimed at our students who come from another country and who need some additional support in getting their English up to the standard required going forwards. So these are not compulsory sessions. They are there, as I say, primarily for people for whom English is a second language. Now, just to say, in terms of the nature of the forthcoming academic year, at the time I'm making this video, I can't say anything about how that year is specifically going to look. What I can say is that in the period from Easter 2020, where we've been teaching remotely, we have delivered our lecture material through video, and I'll talk a bit more about that a little bit later. And students have largely been working to the same schedule. So they've been basically studying the material during the time slots shown here. They've had assignments to do. It's not been possible for us to do practical work, but it hasn't been necessary because actually they completed the vast majority of the practical work before we finished at Easter. In terms of the workshop material, again, this has been made available online, and we've run some sessions where students have been able to attend via the software we use, which is Teams. It has similar functionality to Skype or Zoom. So there has been interactive teaching going on. Students have been able to approach us to ask questions, and I should say the evaluation that we've done has proved to be shown that the students have found this very positive. So that's just a word on how things have worked at the moment. As I say, I can't comment too much on how things are going to look next year. We may find that we are able to operate in terms of business as usual, but as I say, at the time I'm recording this, I can't comment further on that. So in terms of how our modules are broken down, well, here is this is what I call a unit descriptor, which goes as part of the chemistry module which I teach on. We tend to break it into units over the course of the year, which cover a fortnightly period. There'll be 6-hour-long lectures in chemistry during that time. Normally a 2-hour workshop each week, and then a 3-hour practical, but one of those in chemistry, because remember what I said, you do biology one week and chemistry another week, and that pattern will happen throughout the course of the year. So for each of the units we teach in chemistry, there's a description of the content that's covered and a list of learning outcomes. Actually, as I speak at the moment, students are preparing for an assessment period which is coming up, and they are in many cases actually going through these learning outcomes now and colour coding them. So they've highlighted them green if it's something they're confident with, yellow if they're a bit unsure, and red if that's a topic they need to work on and get their head around before they get the final assessment. So actually these lists of learning outcomes in the chemistry module actually tend to be very useful. The pattern here in terms of the amount of time spent would be the same for the biology module as it is for chemistry. For the maths, as mentioned earlier, this is a 15 credit module. There is a bit less time allocated to it, but actually it's considerably more than half of the time we give to the other modules. This is to recognise the fact that a number of our students do find maths quite difficult. So we do allocate a lot of time, a lot of staff time to support students in this area, and that's highly valued by the students. Now, in terms of the teaching and the resources we make available, the foundation year at Southampton is well known for teaching innovation. So certainly in our face-to-face lectures, we've done a lot of stuff with in-class voting technology. So in this case, this is using some software called Vvox, where students have their mobile phones, questions appear on the screen, students vote, and then the responses of students appear as shown in these charts. This is a question I always ask at the start of the year: how do you feel about chemistry? And it's always interesting to see the results, and this was good. I was pleased when I saw this, because obviously for some students coming onto the foundation year, if they want to study in biological sciences, they might not be quite so keen on chemistry. Our hope would be that at the end of the year, students will have a positive appreciation of the subject. Anyway, this helps to encourage interaction within the recordings, or within the lectures rather. But on the note of recordings, where we've been making recordings available, we've actually been using quiz questions embedded within recordings to try and introduce the same level of interactivity, and that's proved to be very popular with students. So on the note of recordings, even when we're teaching face-to-face sessions, we always record our lectures, so these are available to students later on for them to reinforce their learning, to revisit the lecture and look at any material that they perhaps didn't really understand first time round. So it's a chance to make those notes a bit more comprehensive, to perhaps listen again and then go and look things up in a textbook or online and refine your note taking. Students are very positive about having recorded lectures available for them. It's also allowed us to use a technique called flipped teaching. So students can watch a recording, which in our case would normally be between 10 and 15 minutes, based on the introductory material for a lecture. They'll watch that at home, then they'll come to the lecture with that background knowledge already in mind, so that when we teach the more complex, higher level material, they find it easier to access that. It also frees up some time for us to have more interactivity in that session. So this actually was incredibly useful for us when we started doing the remote teaching after Easter in 2020, because we already had a lot of experience of making use of this kind of video technology, and as I say, the students have been incredibly positive about the work that we've done in providing them with online resources to support their learning. Our assignments largely are submitted electronically. This means we can mark them electronically, so we are able to provide rapid feedback. We use some software called Turnitin, which it's famous for its plagiarism check, so we can identify whether or not students have copied information from each other or from internet sources. But it does mean we can also provide quite detailed feedback comments and add audio feedback and that kind of thing too. So yes, we've been well known for our teaching innovation over the years, and our students have responded very positively to the work that we've done. Here are just a few words from some of our former students. I'm not going to go through those in too much great detail, but Sylvia here was a student who took the foundation year back in 2014. She's gone on to achieve a very high quality degree in chemistry. She's now studying for a PhD, where she's using one of these big machines here. This is a nuclear magnetic resonance machine. John here did the foundation year quite a period of time ago now. He's since gone on to be a school teacher and has been very successful in that endeavour. And Georgia here, who went on to study biology after doing the foundation year in 2015, has gone on since to do a master's in biology as well. So many of our students actually go on to do extremely well on their degrees, but then also often go on to do PhDs afterwards. And we have a number of former foundation year students in quite important roles still working in the university now, 20 years on from their foundation year. So there's a long track record of people having great success after studying with us. So I hope that that is useful information for you. Obviously, I'm not going to go into detail about employability and that kind of thing because it's not relevant to the foundation year programme. You should find out about that information from the talks that are based on the subjects you want to go on to after a foundation year. However, if you have any questions, I'm very happy to be contacted anytime. My contact details are here, and I will be available on the virtual open day to answer any questions you have then. As I say, please feel free to contact me anytime after that. No problem. I'll look forward to hearing from you.